Comparison of encryption techniques in Internet of Things. Abstract: there are 20 billion IoT devices in the world. The major difficulty facing the industry is the security and privacy of the data that is transmitted in IoT networks. This can be overcome with the use of encryption during data transmission. Here we analyze the working of different encryption and their use cases. A good encryption technique will only reveal the content of the data transmitted to the intended recipient. We cover some popular and promising encryption techniques like Advanced Encryption Standard, EAS, RSA, and Fish algorithm, and also the hybrid encryption in cloud computing. Keywords: encryption, Internet of Things, Advanced Encryption Standard, Fish encryption, cloud computing. Introduction. Internet of Things, IoT, is a fast emerging industry of interconnected devices. These devices share information with each other, and the protection of this information is of massive importance. An IoT system consists of web-enabled smart devices that use embedded systems to collect, send, and act on data they acquire from their environments. These IoT ecosystems collect data from the various sensors to an IoT edge device where it is then stored and analyzed locally or on the cloud. The large amounts of data that is gathered from the various sensors can then be used in the fields of machine learning and artificial intelligence. These IoT networks can therefore automate many processes with many different devices working together. Some of the major applications include smart homes and smart manufacturing, which will significantly improve our lives. It also can enable businesses to cut down on waste, improve service delivery, and reduce labor costs. The installed base of IoT devices is forecast to be 20 billion by 2022. This gives us the ability to access information from anywhere at any time on any device. Since a large amount of these IoT devices will be in the hands of everyday people, it is of extreme importance to protect their privacy. Since IoT devices involve billions of data points, it has an expanded attack surface which can compromise sensitive information about the user. For example, in 2016, a botnet infiltrated the domain name server provided Dyn and took down many websites for an extended period. This was one of the largest DOS, distributed denial of service, attacks that occurred after the hackers gained access by exploiting poorly secured IoT devices. This goes to show how, since all IoT devices are connected, all an attacker must do is exploit one vulnerability to access all data. Which is why encryption is the need of the hour to protect IoT networks from their biggest threats. Most industry experts believe that IoT security and IoT privacy are cited as major concerns for IoT industry. In simple terms, encryption is the process of scrambling sensitive data into an unreadable format. This data is used to encrypt using a special encryption key. It can only be read using a special decryption key. This ensures that only the intended person can access this information. Without encryption, all the data that is sent in IoT systems can easily read by anyone who intercepts this transmission. Some of the most popular encryption methods are 1. RSA. 2. Advanced Encryption Standard, EAS. 3. Fish. Encryption ensures that data stored in servers can only be accessed when privacy and exclusivity of data are both guaranteed. Hence, it protects and isolates data between users, companies, and other people involved or with access to the data. This also ensures people and companies build trust knowing that their sensitive data is safe. This is why encryption should be used in every IoT device. Security is also the key for IoT to fulfill its full potential. This data can then be analyzed with machine learning tools and other patterns. This helps find patterns and conduct research, etc. However, if all this data is readable, it makes the whole IoT network very vulnerable. Encryption therefore ensures machine learning data sets can be very large while also ensuring privacy. Another industry where encryption is of utmost importance are the wearable and healthcare industries. This ensures that sensitive medical data can be used to predict illnesses, but also that it is not readable to everyone. This paper deals with some common encryption and compares and contrasts their different use cases. 2. Related work. A. Binary bit sequencing and multi-stage encryption algorithm. This is a new symmetric cryptography algorithm and uses the symmetric key provided by the user 1. The same key will be used to encrypt the given information, making use of the projected algorithm. In this technique we substitute the plain text with the cipher text by performing operation on the binary bit sequence of the plain text. The key provided by the user must be between 0 and 255. Overall simplified concept of the symmetric cryptography process is shown in Fig 3. Important causes of using the symmetric key for encryption and decryption are 1. Process is easygoing. 2. Security is dependent on the key. 3. Both the dispatcher and the respective recipients can use the similar keys and processes for encryption and decryption techniques. Proposed encryption algorithm. Initially we need to define some character values that we'll use to replace the plain text. Defined characters equals 2n/2. N is binary bit sequence. 1. Read the plaintext message from user. 2. Replace the plaintext by their ASCII values. 3. Read a secret key from the user. 4. Perform the XOR of ASCII values with the key provided by user. 5. Converting numerical values in the binary n-bit sequence. 6. Converting the received n-bit sequence in the n/2 bits binary sequence. 7. Converting the n/2 bits binary sequence in the decimal format. 8. Changing all the decimal values with respective character from the character table. 9. Transmit the cipher text. Proposed decryption algorithm. 1. Use the same character table used in the encryption process. 2. Reading the cipher text from user. 3. Replacing cipher text by their numerical values. 4. Reading the secret key from the user. 5. Managing the binary bit sequence. 6. Performing the XOR operation of binary bit sequence and secret key. 7. Performing reverse character substitution. 8. Processing the plaintext. Advantages. 1. Algorithm uses minimum memory. 2. Algorithm works fast and is time efficient. 3. Multistage encryption is used by this algorithm. 4. Algorithm is quite simple and more secure. 5. It requires n attempts to crack, so algorithm is more robust. Disadvantages. On an average the encryption and decryption time is comparatively less than Rivest-Shamir-Adleman, RAS, algorithm but more than EAS algorithm, which concludes that EAS is more efficient than binary bit sequence algorithm. B. Advanced Encryption Standard. The Advanced Encryption Standard, EAS, is a fast and secure form of encryption that keeps attackers away from our data too. Important features of EAS. 1. EAS is a symmetric key block cipher. 2. EAS gives whole specification and design details. 3. EAS uses large key sizes. Operations of EAS. EAS does computations on bytes. EAS uses 128 bits of a plaintext block as 16 bytes. These are arranged in 4 columns and rows. EAS is variable dependent the length of key. An EAS cipher specifies the number of repetitions of conversion rounds that exchange input that's called plaintext, and also the resulting output is termed ciphertext. Encryption. In this algorithm the input information is taken for encryption. The transform this data into hexadecimal number and perform shift rows operation to remodel this hexadecimal number into rows and column for encryption. In shift rows operation the initial queue is unchanged. Each byte of the subsequent string is shift individual near the GON. Within the same way, third and fourth queue be shifted. In shift rows, transformation may be a permutation. Then perform mixed column transformation to convert each column key on an imaginative line. In column conversion, make original column standards by applying expressions to convert the input column. An expression can contain variables, function, operator, and column from the transformed input. And so adding some round key to every column to perform the addition of matrix. Finally, XOR the output of the addition of matrix with key. Decryption. In this algorithm, firstly input file is taken for decryption. At the moment, transform this data into hexadecimal number and then perform shift rows operation to remodel this hexadecimal number into rows in column for decryption. In shift rows, the initial queue is gone unchanged. Every byte of the following string be shift individual near the gone. Similarly, third and fourth queue be shifted. In shift rows, transformation could be a simple permutation. After that, do mixed column transformation to convert each column key on a original line. In column conversion, make original column standards by applying expressions to convert input column. An expression is able to contain variables, function, operator, and column from the transformation input. Then add some round key to every column to perform. Advantages of ease. 1 is it is implemented in both hardware and software. It is most efficient security protocol. 2 it uses high-length key sizes such as 128, 192 and 256 bits. 3 it is used for wide various of applications such as wireless communication, financial transactions, e-business, encrypted data storage, etc. 4 it is faster than traditional day algorithm. 5 exceedingly difficult to hack any personal information. Disadvantages of ease. 1 it uses a remarkably simple algebraic structure. 2 always every block is encrypted in the same way. 3 difficult to implement with software. C an encryption-based secure framework. The solution for a security issue in Internet of Things, IoT, routing is to utilize straightforward protocol with a strength of scrambling data with the private key for. For this, arrangement should be done in the existing bundle structure. This procedure can be followed with any routing protocol as it just includes a change to the information part of the client. These keys are likewise put away in each base node alongside the one-of-a-kind ID of the bit. All the client's information and messages are scrambled utilizing an arbitrarily chosen key from the encryption key. On the off chance that the client information is to be encoded, then an atypical 7-bit design is additionally scrambled using a similar key. It can be each of the ones, 111,111, or every one of the zeros, 0 million, or combination of zeros and ones. This example is used to limit information unscrambling at the base station as decoding huge information will take even more preparing time and figuring powers. The data is sent utilizing typical routing strategies. The base station first tallies if the received message is scrambled or not, which is found on the main piece of client data. In encrypted bundle, the 7-bit design is unscrambled using all the keys and the decoded string is coordinated against putting away piece design and a match is discovered at that point by utilizing coming about mystery key. Whatever is left of the messages are decoded. DRSA algorithm. As the applications of Internet of Things become more and more popular, the security requirements become a major factor. There emerges the need of encryption techniques to protect the data communicated between various IoT devices. Comparison of major algorithms is done in the paper to ensure that there are two types of encryption techniques, namely symmetric key and asymmetric key encryption. The symmetric key technique has a concept of a private or secret key which will be used to encrypt the information while sending. At the receiver's end, the same key is being used to decipher the message 5. In asymmetric key encryption, there is a pair of keys for each receiver called public and private keys. The public key is known to everyone and is used in the process of encoding the data, and the only receiver which has the paired private key can decode the message. RSA is short for Rivis Shamir Adelman, which uses asymmetric key encryption technique to send and receive messages. The algorithm. Key generation. 1 2 prime numbers considerably large, P and Q are taken. 2 the product n equals P asterisk Q is calculated. 3 Euler's totient function is applied for n equals P 1 asterisk Q 1. An integer e is chosen such that it is CO prime to n lesser than n. 4 d is computed such that it satisfies the relation d asterisk e 1 mod n. 5 n and e are served as the public key and d is the private key known to the receiver. Encryption. 1 the message to be sent is transformed to a number m6. Encoding will be done to produce the ciphertext C as C equals me mod n. Decryption. 1 the private key is used on the received ciphertext to decrypt the message m equals CD mod n. 2 with m known, the two initial prime numbers can also be retrieved. Advantages. 1 although it uses complex mathematics, it is safe and secure. 2 sharing of the public key is simple and easy as it is known to everyone. 3 it has a wide range of industry usage. Disadvantages. 1 when the input message to be encrypted becomes large, the algorithm would be very slow. 2 the encrypted message containing the public key is vulnerable to attacks. 3 the generation of the keys is comparatively slow. Fish algorithm. The block cipher is a finite state algorithm which is operated on blocks or combination of bits. The initial bit stream is encrypted by the use of a function which takes another sequence of bits called the key to decrypted by the inverse of the function used to encrypt. The Fish cipher is a block cipher which makes use of the symmetric encryption process, having the input bit size of 128 bits and the key size up to 256 bits. 7. Bruce Schneier first came up with the idea of the Fish cipher, deriving it from blowfish and square. The algorithm. G function. 1 it splits the input word into 4 bytes. 2 each byte is transformed using separate boxes which has different keys. 3 the resulting vector of length 4 is multiplied by an MDS matrix. Encryption. 1 the input text is divided into 4 32-bit words and is XORed and given as input to the G function in cyclic order. 2 the pH transform is used to combine the results of the G function and the order is swapped for the next sequential round. Decryption. 1 the subkeys are reversed and the same procedure is done to decrypt the message. Advantages. 1 it overcomes the downsides of the algorithms it is derived from. 2 the algorithm is not broken till now. Disadvantages. 1 is innate, it is much slower compared to the previous algorithms. 2 the algorithm is not standardized. Hybrid encryption in cloud computing. Cloud computing is a computing process where users store, process, and manage the data by remote servers on the internet instead of local server on own computer. 9. It also provides various models to provide security and protect the information from other people. There are many types of hybrid encryption combining suitable other encryption techniques. A hybrid encryption scheme by integrating RSA and Diffie-Hellman to get data security for the services of cloud is one of its kind. The idea of this integration is to exploit secret key cryptography that includes encoding, decoding process speed and public key cryptography, which is management of key. Diffie-Hellman is an aged encryption technique used internet protocol security. Methodology. Hybrid cryptography strategy embrace the integration of both symmetric and asymmetric algorithms for increasingly incredible outcome. Every cryptography strategy involves the scramble and decryption process. In encryption, first information is changed into non-understandable format, which shouldn't be understood easily by any person. To obtain first information from figure, information decoding process is utilized. In this investigation, two-time encryption and decoding process is performed in light of fact that the utilization of asymmetric and symmetric process. Security issues. 1. Data confidentiality. Due to security reasons, users want the information to be read by right people. So, for this, unknown accessing and using information must be stopped. 2. Data authenticity. Security necessity guarantees the personality of node with which correspondence happens is certified. 3. Data integrity. The security necessity in which messages ought not to get altered while exchanging among sender and beneficiary. 4. Data authorization. Security necessity to guarantee that data dispersal should just from approved sensors. 5. Non-repudiation. It manages retransmitting of message through a node. A node ought not to preclude retransmitting from claiming officially sent a message. 6. Data freshness. It manages keeping up and scattering up incoming data by sensor nodes. Related work. 1. In this paper, the authors have proposed a hybrid cryptography method using two symmetric cryptography techniques: Data Encryption Standard, DE, and International Data Encryption Algorithm, IDEA, for security of sensitive data in military data, banking trades, etc. 10. 2. In this, the author used EASE and Fish algorithm for application in military, bank, in network companies, big websites those control big database, etc. 11. 3. In this, they have proposed hybrid encryption system with Fish and RSA for secure storage for healthcare data on cloud because it minimizes the time for encryption and decryption compared to other symmetric techniques. 12. 3. Conclusions. In this paper we have discussed about the importance of various types of encryption,